All right, so we're going to work example 25 from section 3.3. So we start with how much should be deposited quarterly into an account that pays 5.8% interest. So we already know that R 0.058 compounded quarterly. So it's quarterly. This tells us that I is 0.058 divided by 4. Beginning April 1st, 2018 and ending January 1st, 2024, in order for the accumulated value to be $50,000 on January 1st, 2029. So we need to do our timeline next. Payment starts on 4/18. Okay, next one occurs at January 1st, 2024. Okay, those are regularly scheduled every 3 months, so you can just put 3 months later to indicate your quarters. And then our last payment is January 1st, 2029. Sorry, not our last payment. That's when we are having our $50,000. So here is where S of N normally happens, right? So this whole bit right here, this stretch, is our N. Okay, and then from here over, this is going to be our M, the exponent on the other piece. Now, because there's such a big gap between S sub N and where we're actually trying to accumulate that money, what this map means that this is an SN4 problem, SN Forborne, and that's our $50,000. Okay, now these work real similar, and the AN deferred problem, really similar. So what we're going to do is we're going to take this $50,000, and it's going to be R times 1 plus our I, 0.058 over 4. Okay, to the exponent that we need to find, minus 1 over 0.058 over 4 times 1 plus 0.058 over 4. So this is all we know so far. So we have to find N, which will go right here, and M, which will go right here. So we're going to just bump this over to work over here. So I'm going to work it out with that method that we did in class last time, just so you can see it again. So we're going to do section. We're going to start with quarters. So we know we have April and January are part of our quarters. 3 months after April would be July. 3 months after July would be October. So then these are our cutoffs for each quarter. So again, they're 3 months apart because every quarter has 3 months. So we have 2018, 2019, 2020, 2021, 2022, 2023, 2024. So this is our last payment. This is our first payment. So then we go 1, 2, 3. And then fourth payment would be January 19. And then we just keep going, filling in the chart. You don't have to work it this way. You can work it the other way that the book does with the multiplying. I find that I make less errors when I work it this way. So that's what I'm going to do. But again, you're welcome to do it whenever way makes the most sense, because you want to focus on what makes sense so that you can replicate it later. So this tells us that N is 24. And then we're going to keep going with our chart because we have to go all the way out to 2029 here. Okay. So this is when our last payment that it's moved forward. So we're going to restart at 1 because now we're counting the payments, the amount of periods that it moves forward. Now I kind of crammed them in here. Sorry about that. Okay. So then our M here is 20. So now that we know those two pieces, and again, I did the chart method. You don't have to do the chart method. We're going to move it over here. So here we should get 24, and here we get 20. And we're just going to scoot this up a little bit. So now we have 50,000 equals R times this giant thing, this whole mess, is our coefficient, which is a little different than what we've done before. So what I did, we can get the calculator to work, is I inputted this already. Okay, and we get 37.95. Remember, it's going to be a big decimal. We expect that. So then R is going to be 50,000 divided by that answer. Okay, so here we get R is equal to 50. I'm having trouble with the pressure sensor on that. Sorry about that, guys. Just a moment. Okay, so this is going to be 50,000 divided by that answer. So we get 13.17 and 24 cents and 0. So here, when we normally round up for payments, we do have a bit of a discrepancy here because we have that 0. So 1317.24 would be okay, or 1317.25 would be okay. I would accept either. Either one would be fine. The work would end up working out just a little bit different because, again, normally we would round up, but because that one has the 0, it's a little bit more tricky.